Bismillahirrahmanirrahim. Assalamu alaikum, students. I hope you would be healthy and safe at your homes. And I also know that you would be worried about your studies. So for that, Bahria Foundation College, Gori Town campus have started these online sessions for you for your understanding, and I hope that these would be very helpful for you. So as we have done first three chapters during our previous session of pre-ninth session, so we would be starting a new chapter today, and that is the chapter number 4, given on page number 62, structure of molecules. Before starting this chapter, I hope that all of the previous concepts would be very clear in your mind, and you would have a very good understanding of the previous concept. As I have told you for many times that all of the previous knowledge is very important to learn the new lesson. So for that we are going to sorry, we are going to do the brainstorming today. In the previous chapters we have discussed that how atoms were discovered, how atom model of atoms were discovered by the scientists, how the elements are being arranged in the periodic table, and how periodic table help us in finding of different physical and chemical properties of the elements. As well as we have discussed that how electrons are being arranged in the what is that shells of an atom during studying the electronic configuration. Beside all that, we have been discussing this for a lot of time, that the entire physical world is made up of mixture and of elements and compounds. So compounds, when this word came into to your mind, everybody knows that the compound is a combination of one or two same or different molecules, different atoms. So for that we should know that why atoms forms molecules. This is the question, that why atoms form molecules, why can't they stay alone, why they have to form molecule. The number two, if we have studied that noble gases actually remain as monatomic molecules, if noble gases are remaining as monatomic molecules, why they do not form the molecules, what is there in their in their electronic configuration which make them like not non-reactive with any other thing. And the third question is there, that how different substances are made up of same elements have the different properties. We have discussed this, I think discussed this for many times during the class, that the same atom would be there. For example, we have discussed the example of iron, Fe, that the same iron is making the building material iron, and the same iron is basically present in your body as a very important constituent of hemoglobin, without which you would be, you would be having anemia. So why is there that, what is the difference in their arrangement that making iron with two very different attributes. So for this we will be studying and we will be answering these questions, and for answering these questions we should understand that what is chemical bonding and what is structure of molecules, how chemical bonding affect the properties, as I have told you about the as I have told you about the properties of, for example, iron, that how iron is like iron as a building material, iron as a important constituent of hemoglobin. Similarly, how the arrangement makes them to produce different structure of molecules. This is what the chapter name is. So, for example, let's take an example of water. Water is a compound which is found in all three types of state of matter: liquid, solid, and gas. For example, liquid as water, solid as ice, and gas as steam. What is there in the chemical bonding or the structure of this molecule which is actually enabling water to sustain all the three states of matter? What is there? These questions would be answered after the understanding of this whole chapter. So for that purpose we are going to start the first ever question. We are going to answer the first ever question, then why atom forms molecules, or why do atom react, why do atom react, and why do the noble gases do not react. So for the answer of this question, let's say that what is there in the periodic table. You have a very good understanding of periodic table, and I'm very much sure that you now are very, it is very easy for you to get the concepts of periodic table just by looking at that. You know that the periodic table starts from alkali matter and it ends at noble gases. And for that, you all know why the noble gases are noble gases, because the noble gases have their valence shell being completely filled. There's no space of any more electron in their outermost shell. So the noble gases have the electronic configuration of 1 ns2 np6. ns2 np6 means ns2 plus 6, 8. So their electronic configuration, their last shell must have 8 electrons in them. For that, they are known as the inert gases. Why inert gases? If you follow the dictionary to get the meaning of inert, inert basically means to lack ability or to lack the strength when there is no strength. For example, if I said that I'm totally inert today, it means I'm tired, I cannot do any more work. Like, this is inert. So they have they are lacking the ability to react. Why they are lacking to the ability to react? For that, we have to take a look on their electronic configuration. Now look at this. Helium 1s2 2 means their shell is being completely filled, no space for any more electron. Neon 1s2 2s2 2p6, second shell, the valence shell, 2 plus 6 8 electrons, no more space for any other electron. Similarly, argon 1s2 2s2 2p6 3s2 3p6, 3 third shell is the valence shell, 6 plus 2 is equals to 8, which means again they don't have any space for any more electron. This is something like that if for example I'm full, I have eaten a lot and I'm full. Now I will not have any desire to eat more. I'm full. I don't want anything. My stomach don't have any space for any more food. I will not go to the kitchen for making new food. I will not ask my mother or anyone else to please give me some food or things like that, because I am now inactive or very stable. Okay, so this is what we call inactivity or being very stable. I am stable now. I don't need any more, like food now. So this is same for these noble gases, because they are full, their electronic configuration is complete, their valence shell is complete. Now they don't need anything more to get inside them. They don't need any more electron. This is something which we named as octet rule. Now what is this? A chemist, J.N. Lewis, in 1916 explained this thing. He explains that as valence shell of most of the elements is incomplete. You have seen that for 1s alkali metals, except for hydrogen, all the other elements have a space of 7 more electrons in their valence shell. They need 7 more electron, or they can they can just lose 1 electron from them. Similarly, if we go through the whole periodic table and get to the 7a, 7a means 7 electrons are there in the valence shell and 1 electron is missing. They need 1 electron to complete their valence shell. Each and every element except the noble gases in the periodic table are incomplete. They have the incomplete valence shell electronic configuration. So for that, they have a desire, or they want to basically complete their valence shell electronic configuration. Why? Because if they will complete their valence shell electronic configuration, they will become stable. Now now they would not be having any desire to need more. Okay, so they have incomplete valence shell electronic configuration. And how do they complete their electronic configuration? They just gain or lose electrons. I think this example have been discussed for many times, like NaCl. Sodium present in 1a group have 1 electron, and chlorine present in 7a group have 7 electrons. We have discussed this. It is very easy for sodium to lose its 1 electron from its outermost shell rather than getting 7 from chlorine. Similarly, for chlorine, it is more easy to get 1 electron rather than losing 7. So elements basically gain or lose electrons. They basically, what do? They gain electrons. For example, sodium would chlorine would gain one electron from sodium, and lose electron means, for example, sodium is losing one electron from its outermost shell to chlorine, making it NaCl. So while doing that, what do they attain? They attain the noble gas configuration, the nearest noble gas configuration. Why? Now their valence shell would have 8 electrons in total. So G.N. Lewis basically named his explanation as octet rule. Octet rule, octet means the set of 8. Okay, the set of 8 means 8 electron must be there in the valence shell electron. That is how he named this whole. Now if their valence shell would be complete, they would not be needing any more electron for them, and they would be stable, as well as they would not be they would attain the noble gas configuration. So we can define the octet rule as the tendency of atoms to acquire the 8 electronic configuration. Yani means to acquire 8 electrons in their valence shell, and when bonding, when they are making the bond, is called the octet rule. As I have given you the example of sodium chloride, when sodium loses its one electron and chlorine gain its one gain the one electron, and chlorine would have the 8 electrons. Similarly, sodium would have the 8 electron in the valence shell. So this is for the octet rule, for those who have 8 or less than 8 or something like that electrons in their valence shell. What about hydrogen? You know, hydrogen has only one element, one electron its valence shell. What should be the rule for for hydrogen? For hydrogen, the rule is the same. Hydrogen may lose or may gain an electron to complete its outermost shell to attain the stability of the nearest noble gas. And what is the nearest noble gas? That is helium. So for that, the rule is named as duplet rule, in which there is a tendency of atoms to acquire 2 electrons in their valence shell, so that they could have 2 electrons and they could have their valence shell being completed. So this is known as duplet rule. Okay, acquiring 2 electrons in their valence shell. So now I think this would be very clear that why do atoms react? They react to basically complete their valence shell electron. While completing their valence shell electron, it is easy for them to be stable and they will become inert. So for gaining the stability, they follow the rules, the octet rules and the duplet rule, and while doing that, they attain the stability of the noble gas, the inert gas. So this is all for today's chapter. Now what should we do? Should we end it like that? No, we are going to do some task as well. What is the task? Solve example 4.1 given on page number 63, and it is very easy. Why is it easy? Why is it easy? It is easy because it would help you. It is as similar as the question we have been doing in our third chapter. It is about the periodic table. You have to get the electronic configuration, and from the electronic configuration you would be able to know that how many electrons are there in the valence shell. And after doing the example 4.1, you have to do the self assessment exercise 4.1 given on page number 64. And when you will be doing this, inshallah, you will be able to get a very good concept of why do atom react. I hope the lecture was helpful for you. If you have any query, if you have any questions, you can ask during the session, the question answer sessions for the WhatsApp, from the WhatsApp group. And I would really appreciate if the questions would be very much appropriate, and they would be according to the need. Now should we end it like that? I think there should be one more thing. You should also learn the topic why do atoms react, so that everything should be on your fingertips. I would be hoping for your health and your safety, and beside that I wish that you all be working very properly and giving a lot of attention to those studies. Obviously, this is very crucial time for your studies, and I really hope that everything would be very helpful for you. Any queries, you are most welcome to ask me during Tuesday, okay, 2 to 4 p.m. Thank you so much. Allah Hafiz.